Hello, my name is Bott. I'm heading a structure called Nicholas Innovation Center. It's Innovation for Laboratory Automation, an initiative by our institute. For those who are not familiar with Fraunhofer is an applied research institution, partly funded by the German government. We're situated in Stuttgart. And the institute has a long history in automation and robotics. That's why we put a somehow different view on the field of life sciences and automation. And one reason why do we think the industry or the customers need something like Nicholas? It's a complex systems of vendors, clients, which just partly understand each other due to the different backgrounds and the various different disciplines. As already mentioned, our institute comes from other industries, so car manufacturing, machine building, and in these industries, the image of a factory is quite common, and we think that the structures that are used in industries or in factories can be seen in laboratories nowadays as well. So a lot of data is generated, and you can see how out of some base material information and new results are generated. And the question is how needs to be the structure of one of these powerful data factories to be very efficient and fulfill the requirements. And we asked, okay, what is the requirement really the people in the laboratory want to have? They are producing a lot of data, and as we all heard in the last 2 days, more or less everybody's confronted with a lot of, or an enormous amount of data, of results, information, hidden information, which run through the process, some workflows, and to handle all these documentation efforts. And still, in most of the laboratories, this challenge is done by pure manual work. The second question is, okay, I have a lot of data. What can I do with all this data? To produce valuable data was already mentioned this morning, but what is valuable? Valuable for being more efficient, valuable in terms of getting better results out of it. What's this value? And create new innovation by better usage of this data. And last but not least, the cooperation, so sharing information with colleagues, partners, or competitors. That's a lot for a human being, and the question is that the result in today's laboratories, that we have a lot of people there which are confronted with enormous amounts of data, enormous complexity of software systems, of things they are supposed to do, but they cannot do because they are still human beings. And we just put together how these complex structures are looking nowadays, and we think that the laboratories, which were in the past just a unit in a company, which need to generate data for other processes, shifted completely. The laboratories have nowadays a kind of control position in a laboratory instead of a side unit. And if you just write down requirements, you come up with this kind of Lego kind of modularity, which is not a very new picture. I think it's obvious that a good system from the client perspective or customer perspective need to be modular, adaptable, and robust if it comes to changes or problems. But due to the digital transformation, we have a new powerful technology which can provide more than just puzzling of non-intelligent units. And these smart parameters are to get units which are responsive, highly interconnected, and in the end smart. So each system is self-sufficient and has its own intelligence itself. And we all know units like that. Berlin is a kind of complex adaptive system, and we don't care that if we have a fire alarm here, that the fireman will arrive. That's nothing somebody of us has organized. It's just happening. And if you think about a laboratory or a network of laboratories, so by position of a laboratory in a company, parts of the work is already done in this self-sufficient way. Other parts are controlled top-down. Due to the higher complexity in the systems, we will end up in something like this. Perhaps this is a company, perhaps this is a company together with a customer of the company, or a network of companies. As some of you may know, Berlin is a very good example of a city in which parts run very good and parts fail. The city, the head of the city are producing some airport which perhaps will never open. So the question is, how can we set up a complex system like that without destroying our already established and well-running processes, especially if it comes to regulated environment. We cannot just decide, okay, we puzzle around and then test it, and if it fails, okay, we start again. That's not possible in this business. And that's why the question is, how may this connectivity look like, and how can we shape and co-create in this system? And the subtitle, the small subtitle I want to introduce on an example everybody is comfortable with, the Windows operating system. This is the IT architecture, very high level. In the past, I would say in the late 90s, the Windows operating system was dominating the entire field the user, the client can interact with. There were some features, tools like the Internet Explorer, Microsoft Office, or Microsoft Paint. You can use them, but Microsoft has pre-decided what you can use. There was no opportunity to open up the system. The idea is clever from a business perspective. The customer is locked into the system. So you cannot decide, okay, I go to another one. It's more or less impossible. The Microsoft obviously discriminated competitors. They got before the court and paid a lot of money due to this. Okay, but you can make business like that. The main issue is that the maintenance costs for the software grow tremendously if your system is increasing. And this is why Microsoft, others, opened up their system and teared down some of the walls, but the overall software system increased. And they decided, okay, we allow competitors, as here in this situation, the Mozilla Foundation, to use and interact with our customers. And they changed their system as a kind of gatekeeper who is allowed to participate in this ecosystem. And if you look how nowadays Microsoft Windows or Android or Apple is not correct. They are still in the first picture, are operating. You have a very tiny island in the middle, which is the core Windows. And there's an ecosystem around which is still having some flavor of Microsoft, but you just don't see it. And the question is, what's the advantage for a company as for Microsoft? They earn, I think, 20 times more money than in the first picture. And they can reduce tremendously the amount of money they have to spend to maintain their system. So you invite others to get your system established. One famous solution from industries, it's ROS, it's a robotic operating system. You see a lot of, it's more or less the who is who of robotics in the world. And they've decided a couple of years ago to cooperate and say, okay, we develop together solutions, applications, and share them. Because it's impossible to generate every possible movement on a robotic for one company. But they want to generate higher levels of automation and reuse these systems. And ROS was started as a kind of academic platform and then went to an industrial solution with ROS Industrial. And we think this might be possible for the laboratory as well, that, for example, a LIMS or ELN platform may be generated, and you puzzle together the components you need, and the various manufacturers push their focus on a specific expertise, a specific technology they may provide. There is no reason that every LIMS is handling role management, sample management on a base level, but there are high levels and additional features which are required and need to be developed. Otherwise, the maintenance and development cost will grow and grow. I've already talked about operating systems. Most of the LIMS or ELN we see are software which is handling information flows, but it's not an operating system for a laboratory. We thought how may one of these operating systems may look like. So a system which handles all hardware, software, process relation which happens in a laboratory. We called it intuitively LabOS, operating system for laboratory, and put the end user in the focus. So just plug to every point of interaction, to a device, to a working bench, a tiny connector. They are extremely cheap. You can buy them for 50 euros, and just log the interaction of people, interaction with devices, and provide this kind of connectivity. Another part would be that via a kind of connector box, you can handle the you can decouple the development cycles of hardware and software. So right now, you procure a kind of device, a fluorescent reader, or a balance, and it's very difficult to get new software updates because a lot of companies don't want a direct interaction to the clients. You can generate a kind of platform to allow a distinct interface for these update cycles. Another point which was not mentioned, I think, in the last 2 days is using devices, complex platforms as a kind of service. We are still buying devices instead of buying functionalities, features, and having somebody who is an expert in using them. when you try to use a complex microscope, you need somebody who's trained on the microscope for a couple of weeks or even months before he just can start using it. There are experts on using microscopes. Why not putting these parts together instead of buying stupid hardware? And another part is providing personalized interfaces. So right now, we all have smartphones on our pocket, and I would assume that none of the smartphones look similar to each other. The hardware is comparable, but if you just switch them on, they will all look completely different because we have a different taste, we have different interests. The people in the laboratories have different interests or different knowledge. There are expert levels of people in the laboratory. You may use this kind of interface as well. I think in the first talk yesterday, we heard something on integrating old devices to a digital age. And we think that at least in the next 10 years or even longer, these old devices will dominate the laboratories because they are there and there is no reason to put them to waste. But you can empower these devices. We have here a simple dispenser. It's a thermo multi-drop, one of the working horses in a lot of laboratories. And the multi-drop is a good device, but it's more or less a stupid device because it cannot say you that the process has been performed correctly. And we just integrated a very low-cost light fork drop detection to empower the device. So this tiny component here was 200, 300 euros. For the manufacturing, perhaps you have to sell it for 1,000, but you can empower existing devices and get them smart, get an information on the performance, or even learn on the samples you have processed. And however, you can even put it on a parallel dosage unit for 96 volts. So it's a low-cost technology due to the microelectronics, which cost more or less nothing. Beside the automation or the connection between devices, we think that the human in the process need to be addressed. We have a lot of manual work parts in laboratories, and if you read the newspapers, that you can read different numbers, 30%, 60% of the overall people will lose their jobs due to digitalization. The good question is, how shall this be possible in a laboratory and why? Obviously, human people are a cost factor, but on the other side, they are very flexible. You can get a lot of good impulse from them. And here I want to present how a good assistance system may look like and a holistic implementation. And we've seen a lot of control interfaces. Here are classic consumer products. I think most of you may know one of these smart speakers. Here are glasses, smart glasses presented on the CES last month, and here smart earphones. The question is not, will these be integrated in laboratories? So how can we provide a landscape to get them running? All of these systems will outdate very quickly. I will not put a single euro that one of these systems will still exist in 5 years. So can your company spend a couple of millions on them? Perhaps not the best idea. But you can provide a kind of architecture to integrate different kind of these systems, a HoloLens, whatever presenting system. And one part which needs to be provided for that is that you shift the way how information is presented to a smarter, machine-readable, but still human-readable way. And if you go through laboratories and read SOPs, it's very difficult to decide which information is required if I'm an expert lab technician or a young non-trained technician. It's very difficult at the moment. Another issue is to get a better understanding on the behavior of the people in the laboratory. So understand their moods, their emotions, their cognition. So we started to use eye tracking technologies to get better insights, what people are really recognizing during the process. Or, as here seen, really using EEG for that purpose. Another puzzle piece is the documentation. So recognizing what is really done in the process. Here you see a gesture recognition by a sensor system developed in the US. The tiny component here is 150 euros. So more or less nothing. It can detect gestures. And here in the video, if it's starting, yeah, sorry, it's in German, the language. We just tried it on a cell culture bank, and it's after 2 weeks of development, so that's the reason why it's still quite slow and not in real time to the process. And the idea is to get a better understanding if we can detect, due to the movements in the manual process, what really happened. We detect the fingers. In the meantime, we integrated the detection of the pipette and can then propose what was done in the process and really bridge the gap in the documentation. Another puzzle piece is integrating simulation technologies before you really started in the process. Here, another student project realized on a HoloLens. And
Well-planned workplace is for everyone, including those who work in a laboratory. With HoloLens, it's now possible to plan your laboratory in real time easily. With the touch of your hand, you can place your devices, including machines and robots, wherever you want in the real world. There is no need to imagine a traditional 2D laboratory plan with your imagination eyes. Everything now is in 3D and real scale. Got something to do while working on your laboratory plan? Don't worry. Lab Planner saves your progress as you close the app. And when you get back, you can directly see the change you've made. Not satisfied with your plan? You can always start over with the integrated voice command.
looks interesting, but the technologies, all these technologies have very hard boundary conditions. If you try to use a HoloLens for an application which is next to the user, for example, a pipetting assistant, you cannot use it. The field of view you have is on a long distance. And integrate your end users, your people in the lab to test these devices. And last but not least, a very new idea or stimuli we want to push to the market is bringing gamification and biotech laboratory environments together. We invite companies from both markets, both branches, how we can optimize work processes. And here on the side, a citation of a famous movie. New stimuli usually come from a very unexpected side, and it's difficult to generate really unexpected new knowledge, new expertise in this field. So I want to thank you for a nice conference and your interest.
Thank you, Mario. Any questions? What I liked is the what was announced at the Pharma 4.0, Industry 4.0 from the ISPE in Verona, which was called Plug and Produce, which is very similar to what we know about plug and play. You put a USB stick of anything else in the computer, and we all expect that the system will recognize it and implement it in your application. Well, the same thing is happening as well with Industry 4.0 and Pharma 4.4. Is to do this on instrumentation. So if you get a mixer in your manufacturing plant, or if you get something else in your plant, that the system, similar as a USB connection recognition, to do that in your process. Those kind of developments are not there yet, but they are more real than we all think. So also that's probably something which is really to the next level here as well. Any experience with that as well, Mario?
So from the hardware and software side, it's already possible. The main challenge is the business case for the companies in behind. So why can we generate more money or an additional revenue by the systems? If you go to small laboratories, you reduce tremendously the time to get started before you really can do science. If you go to very young companies, they spend about half their effort for getting their laboratory run. And by these systems, this might be faster.
Okay. Thank you very much.